So in the last class, we saw that what are the problems of starting a DC shunt motor direct online or DOL. So these are the problems that may arise if we start a DC shunt motor direct online. So therefore, what precaution we can take, that also we have already suggested in the last class. So we got two suggestions. So one, by reducing the terminal voltage and then gradually increasing it. Another approach is uh, at the beginning the resistance can be kept high. That means some series resistance may be connected in series with the armature, and gradually we have to reduce the series resistance of the armature. So these are the two approaches by which we can avoid this type of problem of dual starting of DC shunt motor. So as I told you that I will discuss only one, that is the gradually reducing the resistance. Okay. Do you have any question on whatever we discussed in last class? If you have, you can ask me. No question?
স্যার বলছি যে যে মোটরগুলো মানে মেইনলি যেগুলো খেলনাতে ইউজ করা হয়, যেগুলো ওই পোলারিটি উল্টো করলে ডাইরেকশন অফ রোটেশনটা চেঞ্জ হয়ে যায়, ওগুলো কি অ্যাকচুয়ালি ব্রাশলেস ডিসি বা এরকম কিছু?
হতে পারে, কিন্তু সেটা দেখতে হবে সেটা মানে এক্সাইটেশনটা কিরাম আছে। অ্যাকচুয়ালি জেনারেলি পার্মানেন্ট ম্যাগনেট যদি হয়, if it is a permanent magnet, then you can change the armature terminal because the field is already fixed. Because permanent magnet, the north pole and south pole you can't change. So generally, small motors are permanent magnet motors. It can be a simply brushed motor. Okay, brushless motor is basically a different technology. It is simply a brushed motor, but it's a permanent magnet motor. So that means instead of electromagnetic field, you have permanent magnet field in the field system. So that means if you have permanent magnet field, then there is no question of changing the field terminal. As we saw in the last class, when we are changing the supply terminal, in case of shunt motor, both the terminal, both the direction is getting reversed. That means both the armature current direction and the flux direction. But if we use brushed permanent magnet motor, then there is no question of flux reversal. So only the armature current will be reversed, and thereby you can get the reverse direction of rotation. Clear? And the advantage of permanent magnet motor is that the motor you can get in a compact size compared to an electromagnetic motor. But still we use the electromagnetic field. Am I audible now? I was disconnected.
Yes, sir, you're audible.
Yes, sir. As I was discussing that why we are not then if the permanent magnet is so advantageous, that means permanent magnet motors are very compact in size. Okay, the first one is you cannot control the field because a permanent magnet means the permanent magnet, so you cannot change the flux. Okay, so you don't have that option, field control option. Electromagnetic field has that option. Okay, so that is one issue. The second issue is in case of permanent magnet field, okay, due to the some high armature reaction, the permanent magnets gets demagnetized. Okay, but nowadays we are using different kinds of permanent magnet, but those technology we don't have. we as a country, we don't have that technology of permanent magnets, and we don't have the minds of the permanent magnets as well. Okay, so as a
Okay, sir.
material technology, we are far behind. So therefore, and another, so this is the problem. Okay, and the permanent magnet what we have, that is generally demagnetized in high armature currents. But still nowadays we are using permanent magnet, but all these permanent magnets are imported. And if we use some permanent magnet machines, and most of the permanent magnet machines or motors are nowadays imported, we don't manufacture that. And if we manufacture, that is also possible, then the cost will be almost 2 times or 2 to 3 times. So no one will buy that. So that is the issue. Otherwise, the permanent magnet motors are very compact and cheap. Anyway, any other query? Do you have any other question? Okay, so that means, as we have seen, that suppose I have a resistance. If we can connect the resistance in series with the armature, so suppose this is the armature terminal and this is the field terminal. What we have to do, we have to connect the armature. Okay, suppose this is the supply. So this should be a variable resistance, and that should be very high at starting. And field should be connected here, because for DC shunt motor, field should be connected across the terminal voltage only. So this is how, that means if we change the armature resistance, initially if we keep the armature resistance high, then gradually if we start the machine, then gradually the EMF, the back EMF will be developed, and we will reduce the armature resistance. Is that clear? So this is the approach for starting of DC shunt motor. Clear? Now why we are not connecting this terminal here? We can also connect this terminal, field terminal here, but we don't connect there. Can you tell me the reason?
তাহলে
The
স্যার এই
field flux
রেজিস্ট্যান্সের
will
ড্রপ
reduce.
বেশি হয়ে যাবে।
হ্যাঁ, হ্যাঁ, ড্রপ হবে তাতে। না না,
The
field
field
current,
flux টা কমে যাবে।
field flux will be
The
reduced.
complete,
বলো।
sir, in shunt machine, the complete terminal voltage should be applied across the field winding. So if we connect this field winding in the
If-
dotted position, then the field current, the entire terminal voltage will not be imposed upon the across the field winding.
But at the end, there will not be any RA, capital RA, isn't it? All this RA will be bypassed. When the motor will gain the full speed or full load rated speed, then we have to bypass this RA. Otherwise, there will be unwanted loss in the armature circuit, isn't it? So then it is okay, na, if we connect the field terminals
sir.
there, isn't it? But not at starting, because for starting you need quite good amount of flux. Otherwise, you know that torque expression. torque expression is Ka phi I. So if we don't have the sufficient amount of flux, okay, then the motor may not get the starting torque. If we don't get the starting torque, then motor will refuse to start, isn't it? Because the starting torque is a finite torque. Why that a starting torque is a finite torque? Because at the starting, motor has to overcome a few losses due to friction and all. Okay, so there is a finite starting torque. So that means at starting you have to provide a finite starting torque to the motor. So if we don't have the good amount of flux, the motor may not start. Okay, and then if we connect the field terminal at the starting at the dotted position, then what will happen? The motor may not start. But at the running condition, when the motor will gain the full speed, then we can connect the field terminal there. Then there is no difference whether we are connecting here or there, because the whole resistance will be bypassed, isn't it? Is this point clear?
Yes, sir.
স্যার আরেকবার বলুন এটা।
কোন জায়গাটা বলো? আমি বলতে চাইছি, if we connect the armature field terminal in the dotted position, suppose in the A position and B position, if we connect the field, the F1 at the A position, then initially what will happen? There is a series resistance Ra with armature as well as field. So for armature it is required, because you want to reduce the starting armature current. Okay, now if we reduce the flux also, that means you want to reduce it. And if you want to reduce the flux also, then what will happen? The net torque will be very less. Okay, so that torque is may not sufficient to overcome the starting torque. But if we connect the field terminal in B position, then directly we are connecting the field across the supply. There is no drop in between. So then we can get a good amount of flux, which will be sufficient to overcome the starting torque. Is it clear? বুঝতে পারছো? না বুঝতে পারলে বলো।
ইয়েস স্যার।
কিন্তু আমি যেটা বলতে চাইছিলাম, at the end when the motor will gain its full speed, rated speed, then we can connect the field at A, isn't it? So that time there is no resistance Ra. Okay, clear? Now another advantage of low flux is that, suppose the expression you already have, the omega equals to, what is the omega expression? Vt
EB by
EB by
KA
KFI, or Vt
into
minus
phi.
IARA by KFI. Vt minus IARA by KFI. Now think, if we can connect this resistance which we are removing from the armature circuit, if we can connect the same resistance in series with the field, then what kind of advantage we can get? Okay, so if we connect the same resistance in series with the field, then the field current will be reduced at the running condition. So that will reduce the flux. So if we can reduce the flux, then we can get a very good amount of speed, because speed is inversely proportional to the flux. Okay, so in some starter technologies, what we do, we connect group of resistances in series with the armature circuit, then we gradually bypass the resistance which are connected in the armature circuit, and whatever the resistance we are bypassing from the armature circuit, we connect that, or we connect those in series with the field circuit, so that we can get a good speed at a full load. Is that point clear? আমি যেটা বলতে চাইছি, কিছু স্টার্টার টেকনোলজিসে এরকম করা থাকে যে আর্মেচারের সাথে সিরিজে গ্রুপ অফ রেজিস্ট্যান্স লাগানো থাকে, যাতে শুরুতে আর্মেচার কারেন্টটা আমরা কম রাখতে পারি। এবার সেই রেজিস্ট্যান্স গুলোই যখন আস্তে আস্তে আমরা বাইপাস করি, কেননা আলটিমেটলি তোমাকে বাইপাস করতেই হবে, তো সেই রেজিস্ট্যান্স গুলো যখন আমরা আর্মেচার সার্কিট থেকে সরাই, উইথড্র করে নিই, সেই রেজিস্ট্যান্স গুলোই আবার ফিল্ড সার্কিটে আমরা কানেক্ট করে দিই, যাতে ফিল্ড ফ্লাক্সটা কম হয়, স্পিডটা বেটার হয়। Is this point clear? Now, এটা ক্লিয়ার হয়েছে?
Yes, sir.
So that means what kind of arrangement we can make. You see, suppose I have a group of resistance like this. Suppose I have 4 resistance. So all these 4 resistance will be connected in series with the armature. So this is my armature. So one chat I got. Okay, so that I will discuss why it is 3 point or what is the 4 point starter, that I will discuss. Just a minute. So let me draw it first. Okay, so it will be like this, and the field is like this. Okay, now field will be connected, as I told you, field will be connected here, and armature will be there. Now we'll create a contact, metal contact here, another metal contact here. So these are all metal contact. Okay, and what we have the supply voltage. Here we have the supply voltage. Okay, and the supply voltage will be connected with a handle. So handle will be at off position. So it is a metal handle. Okay, so this is, suppose this is the off position. So there is no connection with the armature or field. So this is the terminal 1, 2, 3, 4, 5, like this. Okay. And this portion will be shorted like this. So this is a simple circuit. Now you see, if I connect, so am I audible clearly? Because it is showing that your internet connection is unstable.
একটু একটু কেটে কেটে যাচ্ছে মাঝখানে, ঠিক আছে তো?
Okay. Suppose if I move the armature handle here, then what will be the current direction? So current will flow like this. Through the armature, it will flow like this. This will be the armature current direction, and the field current direction will be like this. Okay, so this is the field current and this will be the armature current. So that means if you see the armature circuit, we have all the 4 resistance connected in series with the armature. So that means at the beginning, at the starting, we can reduce the, sorry, this is the armature current. At the starting, we can reduce the armature current, but the field current will be full. Okay, now if I remove or if I move the armature handle into position number 2, then what will happen? Let me see. So if I move the armature handle to this, then what will be the current direction? So let me draw the armature current direction. So this is the armature current direction. So this is the IA and the IF will be this. Just see carefully. Now what is there in the armature circuit? In armature circuit, we have 3 resistance left. 3 resistances left in the armature circuit that will be in series with the armature resistance. One has already been bypassed from the armature circuits, and the resistance which we have bypassed from the armature circuits is connected in the field circuit. So that means field current has gone down. Field current has reduced by this process. Field flux has reduced. Is that point clear? So that means the resistance which we are bypassing from the armature circuit, we are connecting in the field circuit. Okay. Now I will draw the last position. So that means when this handle will be connected here, then what will happen? The armature current will flow like this. This will be the armature current. That means there is no resistance, external resistance connected in the armature circuit. And what will be the field circuit? Field circuit will be this. So that means all these resistance are connected in the field circuit. Isn't it? So that means field circuit, field flux will be very low at the end, so that we can get a good amount of speed. Don't think this type of starter technology is universal, but it's very popular starter technology, you can say. In some starter technology, there is no change in the field current. Or in other type of starter technology, there is a provision of changing the field current. Okay, so actually, if I can see you, show you that. So the starts are like this, and we have a handle like this. Suppose this is the handle. So let me draw with this. So this is the handle. And suppose this is the resistance. Okay. Now, when I will move from position 1 to 2, okay, for some time that resistance will be shorted. When the handle position will short 1 and 2, the resistance will be shorted. When the resistance is shorted, the current will be flowing. That means the current is not discontinuous, but there is a jump in the current, you can say. Current will not be zero at any point, but there will be a step jump in the current, that you can say. Is that point clear? মানে এটা নয় যে 1 থেকে যখন 2 দিলাম হট করে কারেন্টটা 0 হয়ে গেল, সেরকম ব্যাপারটা নয়। Because when we are moving from 1 to 2, then at some point the resistance will be shorted. Okay.
Sir, please repeat this again.
I am saying that when you are moving the arm from 1 to 2, at the, so again it was disconnected, I think. Is it okay now?
Yes.
Is it okay?
Yes, sir.
So the connection is giving a trouble today.
Uh.
Now I am saying that when I am at position 1, so the handle
Sir,
is
আপনি স্ক্রিনটা শেয়ার করেন।
screen share করা নেই। Okay. Now it's okay.
Yeah, yes, it's coming.
It has come.
No, sir.
No, sir.
No,
It is
এবার
showing.
এসছে।
Yes, sir. Yes. Yes, sir.
You can see the screen.
Yes, sir. Yes, sir.
No, there will be no such problem because the jump in current is less compared to the initial jump. So if we go for direct online starting, then the jump which you can expect, now the current jump is very small compared to that jump. Here also the current will jump from 1 to 2 when we are moving. The current will jump, but that step size just wait for some time. I will switch my connection. Now it's okay.
Yes, sir.
So I have changed the connection. So let's see whether we can continue with this or not. Okay, so this is the technology of the starter. Then there are two versions of starter is available. One is called the 3-point starter and another is called the 4-point starter. So the change is very simple. Now you see, when we are moving this arm to this position, position number 5, okay, we have to keep at position number 5 for some time for running condition. Otherwise, if it returns back to position number 1, then again the motor will switch off, isn't it? So therefore, suppose this is the off position and suppose this is the arm which is at the off position initially. Suppose this is the arm. Which we can move from position 1, 2, 3, 4, 5. Okay. Now at the end, you need some magnet which will hold this particular arm, and we need a soft iron there with the arm. Okay, now this is the holding coil which will keep the arm at the farthest position. Okay, and suppose here you have the supply. Here you have the supply which is coming from a DC source. Okay, you may have two pole supply. Okay, now one more thing is required, that is should be there for any machine, that is called the overload relay. So there should be some arrangement for breaking the circuit if the current is exceeds the upper limit. Okay, so for that there should be some overload. So overload system is like this. So this is the overload system. Okay, and it is connected with this. Then here you have all these resistance connected. Like this, and this will be connected with the field. That means here you have the machine, here you have the armature circuit. Terminals are A1, A2, F1, F2. So this is the machine part which has 4 terminals. I already told you that shunt motor will have 4 terminals. So this is the machine. So this is the machine part. So this is the DC machine. Okay. And this connection which will come out from this number 5 will be connected with armature, and this connection will come from this point and which will be connected with the field. So this is how you have 3 terminals coming out from the starter. So these are called the line terminals, field terminals, and armature terminals. So these are the terminals of the starter. So this is the starter. So how many points are coming out from starter? L, A, and F. So therefore it is called the 3-point starter. Okay, so it's called the 3-point starter. Now how we will manage this overload? So this is the overload relay. Overload relay. Now how we will manage this overload relay? So there will be a plunger like this. Okay, so plunger like this, and there is a circuit contact like this, and this will be connected here, one terminal here, another terminal. Just a minute. So another terminal here. Just a minute. This. Okay. Now how we'll connect the machine? When we'll connect the machine, we'll connect the one terminal of the supply to this L. Okay. F will connect to F1, A will connect to A1, we'll make A2, F2 short, and this shorted terminal will connect to the supply. So this is how we connect the DC machine to the 3-point starter. Is that clear? So suppose বলছি আমি একটা ক্লাসে আছি, বুঝেছিস? আমি তোকে কল ব্যাক করছি, হ্যাঁ? Suppose these are the 3 terminals coming out from the starter, L, A and F, and from the motor we have 4 terminals. Motors we have 4 terminals. What are the 4 terminals? F1, F2, A1, A2. Okay, and supply has 2 terminals. Supply has 2 terminals. So how we'll connect? As I given in the figure, so we'll short it L1. A will be connected to A1. F will be connected to F1. A2, F2 will be shorted like this, and this shorted terminal will return back to supply. So this is how the starter is connected with the motor. So this is the starter and this is the DC shunt motor. Now clear? Clear this scheme?
স্যার একটা ওভারলোড রিলে আরেকটা কি?
So this is the holding coil. This is an electromagnet. So I will explain this. Now when I am moving this handle to its extreme position, that means when I am moving this handle to this position, what I want to keep the handle over there so that the machine can run with its full voltage, isn't it? So that means to keep the handle there, because if we leave the handle, there is a spring which will draw the handle to its off position. So this is the mechanically stable position of the handle. So this off position is basically the mechanical stable position of the handle because there is a spring. Okay, so if we leave the handle at position number 5, it will try to return back at off position because spring is connected with this. But what we want to keep the handle position there so that the motor can run at its full voltage. So for that, what we need an electromagnet which will hold the arm at position 5. So for that we have created this holding coil for this electromagnet. Now this holding coil is connected in series with the field. Can you see this? This holding coil is connected in series with the field. Okay. Now, so that means when it is in position 5, the holding coil will be energized and it will hold the arm at the position 5. Clear? কি বোঝা গেছে এটা? Only problem is that as you are connecting all these resistances in series with the field, so when the arm will reach at the position 5, then the field current will be so weak, the holding coil magnetization will be very less, and it may not have that much energy or power to hold the arm at that position. So sometimes the holding coil can be demagnetized and the arm will return back to its off position. So that is the main disadvantage of this scheme. What I want to say, as I have connected, or as it is, the holding coil is connected in series with the field circuit, when the arm position will be at 5, then the current flowing through the holding coil may be insufficient to magnetize the electromagnet, to create sufficient force to hold the arm at position 5. And if it is the case, then the arm may return back to the off position. Okay, so that means automatically the motor will switch off. So that is the problem with this screen. Okay, and what is the function of OLR, that I also explain you, that this OLR, you see how it is connected. It is connected in series with the line current. You see, the AL is connected to OLR. OLR is connected with this. Suppose the arm, when the arm position at 5, so it is connected with the line current. So if the line current is beyond a threshold value, then this particular electromagnet will be energized and it will draw this plunger. This plunger it will draw and it will short these 2 points, P1 and P2. So these 2 points it will short, and if it short like this, then also the holding coil will be demagnetized and the arm will return back to the off position. So this is how it will protect the machine. HC full form is holding coil. Just a minute. So somebody asking that whether we can call it NVRC. What is that? No voltage release coil. Why? Which one? Which one we should call no voltage release? হ্যাঁ কোনটা বলো? Holding coil means it is basically an electromagnet. Holding coil is basically the magnetizing coil for the electromagnet, which helps to hold the arm at the full load position number 5. এই তো। ওকে, সেটা তুমি যে নামে খুশি ডাকতে পারো। হ্যাঁ বলো কোনটা?
Sir, will you please repeat the function of OLR once again?
Correct. I will do that. Now Wheeler coil of this Wheeler Wheeler, that means the overload relay magnet, the coil is connected in the line. In line means, suppose here the line current will flow, isn't it? So here the line current will flow. Oiler is connected in line. So that means when the line current is above a threshold value, what will happen? It will pull this plunger towards this. This plunger, which I have drawn here, this is basically a iron plunger. So it will move in this direction. Okay, now if it moves this direction, then it may short these two. So that means this P1 and P2, two terminals which I have drawn here. So it may short P1 and P2. Initially they are open. Okay, so it will short P1 and P2. Now if the P1 and P2 is shorted, let's see what happens. You see, if P1 and P2 shorted, then this holding coil will be shorted. If the holding coil is shorted, if there is no current in the holding coil, then what will happen? It will leave the arm and the arm will return back to the off position. That means you are protecting the machine from this overcurrent or overload. যখনই কারেন্টটা আইম্যাক্স এর লাইন কারেন্টটা আইম্যাক্স এর চেয়ে বেশি হয়ে যাবে, এটা হতেই পারে যে মেশিনটা ড্যামেজ হয়ে যেতে পারে। সেই জন্য আমরা কি করছি? আমরা এমন একটা অ্যারেঞ্জমেন্ট করে রেখেছি যাতে আর্মটা অফ পজিশনে চলে আসতে পারে, মেশিনটা অটোমেটিক্যালি অফ হয়ে যায়। That point clear?
Yes, sir.
স্যার ওয়েলার এর ফুল ফর্মটা একবার বলবেন?
Overload relay. OLR means overload relay. I have mentioned that what is the disadvantage of this scheme. Can you tell me what is that? So these 3 points starter has a certain disadvantage. What is that?
Sir, in the running condition, the entire resistance is in series with the field coil. So the field current is very less, and if this is very less, so the holding coil current is also very less. So the holding coil power can be so weak that it cannot be able to hold this starter handle at the position 5, and the starter handle may be disconnected and it return back to off position. The machine will stop.
Correct. So that means if the field current is very less, then the holding coil current will be less because they are connected in series. So that means it may leave this arm and the arm will return back to the off position. That means for a weak field excitation, the machine will be automatically switched off. So that is not desirable. Isn't it? So what correction we can make here? We can incorporate here. What correction we can incorporate here? Now we can connect this holding coil independent of this field current, isn't it? So for that, let me, so you can draw a different figure, but I will change the figure here itself. Okay. Suppose I am directly connecting this with the field. Okay. Clear? And I am tapping this holding coil from this okay, and I need some resistance, otherwise the field current will be very high. So this is the correction which we can make. Have you understood this correction? Now what will happen? The holding current is independent of this field current. Isn't it?
স্যার এক্স্যাক্টলি ইন্ডিপেন্ডেন্ট হলো কি?
এক্স্যাক্টলি ইন্ডিপেন্ডেন্ট হলো বলতে ফিল্ড কারেন্টের সাথে তো ইন্ডিপেন্ডেন্ট, ফিল্ডের সাথে তো সিরিজে নয়, এটা রেজিস্ট্যান্স গুলোর সাথে সিরিজে অবশ্যই। অ্যাকর্ডিংলি ইউ উইল ম্যানেজ দিস, ইউ উইল ডিজাইন দিস রেজিস্ট্যান্স, they are connected. Okay, so it's completely independent of the field current. So I have tapped before the field itself. Okay, you see, I have tapped it before the field itself. So thereby I am getting 4 terminals instead of 3. And this is called the 4-point starter. Okay, so this is the 4-point starter, where we can overcome this problem of weak holding holding coil current.
স্যার তাহলে তো এখানে মানে এই সিরিজ রেজিস্ট্যান্স গুলোর ভ্যালু খুব বেশি হওয়া যাবে না, মানে যাতে, কারণ তাহলে তো 4 পয়েন্ট স্টার্টারের ক্ষেত্রেও হোল্ডিং কয়েলে কারেন্ট খুব কম হতে পারে।
No, that you can actually, that resistance is there by which we can design this.
But
You
if
cannot.
the resistance is very small, then the
Which one?
field current will also reduce.
No, you
This
see,
R, capital
here
R.
this field resistance is quite high compared to this armature resistance. And if you just try to think, suppose this in the order of 1 ohm, this in the order of 100 ohm, this may be in the order of say 5 ohm. বুঝতে পেরেছো? So if you are always if you connect the holding coil in series with the field, so always you are allowing very small current to the holding coil. বুঝতে পেরেছো?
হ্যাঁ স্যার।
You convinced or not?
ইয়েস স্যার।
If you are not convinced, you just tell me. You just let me know if you are not convinced. So I can
ইয়েস স্যার, আন্ডারস্টুড।
actually the resistances can be calculated. It's not equally distributed, as I have shown. It is 5 5 5. It may not be like this. They are actually designed with different values. Okay, but that is very less. I think in the order of armature resistance only. So in the order of 1 ohm only. It may be 5 4 3 2 like this. Not in the order of field resistance. Field resistance is, shunt field resistance is quite high, in the order of 100 150 200 like this. So if we connect this holding coil in series with the field coil, so always you are allowing very small current to the holding coil. So that means you have arranged some electromagnet, but you are not fully utilizing that. Okay, now let me draw the connection for this. As we have, so this is the 4-point starter. So we have 4 point So the points are L1, L2, A and F. The same starter you will find in our laboratory, and we have a machine. This is shunt motor. And remember, always remember this connection, because you have to use this connection so many times up to 4th year. So you just see how we connect this. So as I told you that A will be connected with A1, F will be connected with F1, this A2, F2 will be shorted. Okay, and here we have the supply. In our laboratory, we have double pole supply. Then we have a fuse at both the lines. Okay, so this will be connected directly to this L1, L2, and this shorted terminal will return back to this L1. So this is how you have to connect the DC shunt motor with a 4-point starter. Clear? So try to remember this connection. So you have to make this connection many times in our laboratory. This connection is similar, which we have drawn here, the previous circuit. Okay. Any question?
Sir,
Follow.
yes, sir. Sir, when we drew this characteristic diagram for DC shunt motor, we consider that flux would be constant. But here, when we are moving handle from 1 position to 5 position, current in the field coil will be changing. So do the flux. So,
Huh?
so those characteristic diagrams are only from
Hmm.
5 position. We have considered this
I'm not getting you.
when we considered flux.
Huh?
Yes, sir. I'm saying that we considered flux would be constant in DC shunt motor when we drew characteristic diagram. So it would be linear, and in case of
Huh?
DC series motor, it would be parabolic.
Huh?
But here, when we are moving this holder from position 1 to position 5, in
No,
field coils,
this is for
flux would be
starting of
changing.
that. So this is the starting of that.
Yes, sir.
This
Yeah.
is not for the characteristics.
Okay,
Characteristics,
sir. Yeah, that is what I wanted to ask.
characteristics. When we
For steady state.
when we want to draw the characteristics, then we have to independently control these parameters. So that means we have to independently control the torque. Accordingly, the speed will vary. So that is different from this starting phenomena. Starting phenomena will exist for hardly 30 to 40 seconds.
Okay, sir.
Okay. Swastik is asking for the advantages in 4-point starter. So in 4-point starter, basically we are connecting the holding coil independent of the field, as field offers very high resistance. So in 3-point starter, if we connect the holding coil in series with the field, we allows very small current through the holding coil. And in the running position or at the position 5, if the holding coil energization is very low, the electromagnet can leave the arm and the arm can return back to the off position and machine will automatically switch off. So that is the problem of 3-point starter. So therefore, in 4-point starter, we made some modification. What is the modification? The modification is that we connect the holding coil independent of the field circuit. We tap before the field circuit itself, and we make a additional path for holding coil. Okay, so holding coil is connected uh, with a different path, and we connect another resistance R, because if we connect directly holding coil to this tap position, the holding current may be very high. So therefore, for adjustment of this holding coil current, we have kept a resistance R as given in this figure by circling. Okay, so that is the advantage of 4-point starter. So we can get a good energization of holding coil at running condition. So next I will start the speed control. Another chat I got. Let me check. Okay. If you have any doubt, you can ask me.
Sir,
Actually, 3-point starters are nowadays obsolete. DC machine becomes obsolete nowadays. This is shunt motor.
স্যার বলছি ক্যাপিটাল আর এর ভ্যালুটা আমরা কিরকম নিই 4-পয়েন্ট স্টার্টারে?
That you have to design so that the holding coil which have used there, so that the current through the holding coil doesn't beyond a limit. বুঝতে পেরেছো?
ওকে
মানে
স্যার।
হোল্ডিং কয়েল কারেন্টের উপর ডিপেন্ড করছে তোমার এই আর এর ভ্যালুটা কত হবে। হ্যাঁ, এবার পুরোটাই ডিপেন্ড করছে অনেক কিছু ভ্যালুর উপর, অনেক কিছু জিনিসের উপর ডিপেন্ড করছে। তোমার মেশিনটা কত ভোল্টেজে তুমি রান করবে, 110 না 220 না 440, বুঝতে পেরেছো? The terminal voltage we are giving here, so that can be a different range. Your machine can be 48 volt machine, your machine can be 440 volt machine, so almost 10 times the voltage, supply voltage can vary. So accordingly, the holding coil design will vary and the resistance design will vary. So that we can't say that what exactly value we choose universally. Any other question? So speed control of DC motor will start, and this is very important topic. Now we can control the speed of the DC motor by
Sir, can you
3
hear me?
different ways.
Sir?
হ্যাঁ বলো, কে কিছু
Sir,
বলছো?
this is the starter. Yes, sir. I am saying something. Ahon.
বলো।
Sir, you said that the this type of 3-point and 4-point starters are used for DC shunt motors. What about the DC series motors?
For DC series motor, simple series resistance is used. Okay, and there also we actually vary the armature resistance, because for DC series motor you don't need this type of complex connection, because all this series and a series field and the armature is connected in series. Okay, so if I
Okay.
let me show you, you just wait for some minute. I'm just showing you. I don't know whether I can, as you have mentioned, I have to show you that, but it is not, cannot minimize this. Just a minute. Can you see these sheets?
Yes, sir.
So this sheet already you have, I think Adam has mailed to you. This is the instruction sheet for our laboratory. Okay. First, I will show you that. Okay, so I am not finding it out. I will show you definitely. So that is basically called the drum controller, by which we control the speed of a DC series motor. And the similar controller we use in trams and EMU trains. Okay, so we have also 2 drum controllers installed in our laboratory. Okay, so you have that experiment in the second semester, I think. So if you have the sheet, then also you can find out that what is the circuit for drum controller. But I am not finding it
Okay,
out
sir.
for this time.
Okay. sir.
Okay. Now, I was discussing this speed control of DC motor. Now, as you have seen that omega is EB by KA phi, or we can write dt minus IA RA by KA phi. So, if this is the case, then what are the different parameters which we can vary to control the speed? Okay, so what are the different parameters or what are the options we have? So one option is obviously this VT. By controlling VT, terminal voltage, we can control the speed. Okay. Another option is if we control the armature resistance, then also we can control the speed. Another option is field flux. If we control the field flux, we can also control the speed. So these are the 3 options. Okay, so the first option is as I discussed that armature resistance control. There is a second option I have written here. So armature resistance control. Do you find any other option here? You can tell me. Any other option you are getting here to control the speed? Hmm?
ডিজাইন ওয়াইজ কি এটাকে করা যায়
Design wise, no.
কনস্ট্যান্ট
So after installing the machine only, we can think of the speed control. So once the machine has been installed, then you cannot change the constants. That means the Ka. The Ka value you cannot change. The Ka value is incorporated in the design. So Ka is basically a constant. You cannot change this once the machine is working. So what else we can change to control the speed? Is
So
there
we can
any?
change the armature current.
Is it possible to change the armature current? Now armature current is dictated by the torque. So therefore we cannot change that. The armature current is dictated by the torque, and that the torque is dictated by the load torque. So that I will discuss. So the armature current is determined by the load torque. So you don't have any control on that. According to the load, the armature current will vary. Okay. So generally armature current generally doesn't change. Okay, so first one will take the DC shunt motor. DC shunt motor. Now in a DC shunt motor, the armature current, what is the armature current we can write from this expression? How we can write the armature current? Using that same expression, we can write dt minus Ka phi omega r divided by Ra. Any chat? Armature current is dictated by torque, or torque is dictated by the armature current. Okay, now both are true because the torque, electromagnetic torque, is dictated by the load torque. So at any equilibrium speed, the torque should be balanced. The torque generated by the machine, that is Te, and the load torque should be balanced. So this is called the torque balance, and this comes from the Newton's law only. To get any equilibrium speed or steady state speed, these two torques should be balanced. Okay, now if these two torque has to be balanced, then this current current only can vary to achieve this load torque or this particular Pe, isn't it? Now coming to this, so dt minus Ka phi omega r by Ra, that is the expression of the current. Now DC shunt motor, if I change the armature resistance, so suppose what I am doing, I am connecting an armature external resistance, that is capital Ra, in series with the DC, and I am varying that. In series with armature, I am varying that. Okay, so that means suppose this is 0 value. Next, if I add some resistance, so obviously I will get another expression which will be Ka phi omega r. Can I write this? You just tell me. Or something else I have to change. Hmm? You just see carefully. What else I have to change in this expression? If I add additional resistance in the armature circuit, what else I have to change? Huh?
Sir, we have to change phi.
Phi, sir.
Why phi? Because phi is independent na, in shunt motor. That is directly connected with the field. How RA, capital RA will interfere this phi?
सर आर्मेचर करंट चेंज होगा.
Sir, the
No, armature current
right
change
hand-
only I have written na. So this expression I have written for the armature current change only. So initially the armature current without the
Then is
capital RA,
constant.
the armature current will be IA0. And with the armature series resistance capital RA, the armature current will be IA1. Now these expressions are
The
okay.
IR the constant.
Sir, this is okay, I think.
Okay, so what about the speed? Because you are doing all this for speed control. Whether the speed will remain same. So that is the question.
No, sir.
No, we are our objective is to vary the speed.
Instantly change করবে না
হ্যাঁ ইনস্ট্যান্টলি চেঞ্জ হবে না
inertia তে।
Okay, that means the current you are saying that current you are taking that current will change instantly, but the speed will not change instantly. Then you can write this, isn't it? So that means your assumption that current change, no speed change. Isn't it? So this, by this assumption you can write this. Is it okay? বুঝতে পারছো আমি কি বলছি? তাহলে স্পিডটা চেঞ্জ হবে কি করে? তুমি যদি ধরে নাও there is no speed change, then how will the speed will change? Okay. Now why we can make this assumption? At what basis we can make this assumption? The basis is there are two systems, electrical subsystem and mechanical subsystems. Now, as you know that electrical subsystem has very low time constant. If you think of an RL circuit, the current takes a very small time in the order of millisecond to reach its full load value, full value. That means the time constant for an electrical circuit is in the order of millisecond. But for a mechanical system where the change of speed is concerned, that takes almost a few seconds. Suppose when you are running the fan above your head, how much time it takes to attain its full speed? It may be 20 to 30 seconds. So that means the time constant for a mechanical systems is large enough compared to an electrical system. So on that basis, we can say when we are changing this armature resistance, instantly the current will change but not the speed. Is that point clear? Now if this is the case, then what will happen if the current changes like this? Now initially you have the torque. Initially you have the torque. What is the torque? Torque you can write, because phi is constant, the torque you can write Ka phi into Ia0. Now the torque becomes different because the current value has changed. Ka phi IA1. Now which is less? The IA1 is less because you have added armature resistance, external armature resistance. So that means we can say that TE1 is less than TE0. Okay. Now if we think of constant torque, so that means if we take constant load torque, if we take, then what will happen? If initially the TE0 was balancing this constant load torque, so this TL, TE0 was balancing the load torque and we are getting some speed omega r. Now, as the value has dropped to TE1, so that means TE1 will definitely be less than TL. Okay, so that means what will happen? If the motoring torque is less than the load torque, then there will be a retardation according to the Newton's law of motion. Okay, if the load torque is greater than the electromagnetic torque, or if the electromagnetic torque is less than the load torque, so there will be a retardation. Okay, and the net torque which will act on it is basically TE minus. Okay, so this torque difference will create the retardation, and now the speed will start decreasing, reducing. Once there is a retardation, then the speed will start decreasing. Is it clear? So initially the speed will not decrease. Once there is a retardation, then the speed will start decreasing. Clear? Okay, so that means now we'll get a new speed. Now what is that speed? What is that speed which we'll get? বলো?
Sir, VT minus IA into RA plus RG.
Now
by
why this value again will be IA?
IA1, sorry. That would be IA1.
If that is IA1, then how the speed will change?
Sir, IA is 0. It will be.
Why it is IA0?
Because speed when decreases, the back EMF also decreases, and
Yes.
that's why the current increases.
Okay, so I have to write
Because
that
current
first,
is
isn't it?
proportional to VT. Yes, sir.
So that means if the speed start decreasing, what about the back EMF? Because back EMF is Ka phi omega. So if omega is decreasing, the back EMF will decrease. Okay, so if back EMF is decreased, what about this IA, which is the difference of, which is a ratio of back EMF by Ka phi, where phi is the constant. So if back EMF is decreased, no, I have written this wrong expression. I এর এক্সপ্রেশনটা কি ছিল জানো? VT minus Ka phi omega divided by
by R.
RA plus Okay, so this is a general expression, RA plus RA. Now in this expression, I am getting this portion decreasing. So if this portion decreasing, that means the Vt minus this portion will increase, the overall increase. So that means the current will increase, which was initially decreased, now it will increase. Okay, so again it will maintain the same torque expression because the torque hasn't changed. The same load torque now also present. So that means it will produce again the value of IA only, IA0 only. So again I will return back to this torque expression because the torque expression should be balanced with the load torque. Load torque hasn't changed, so current cannot be changed. Current should be constant because load is constant. সেই জন্য একটু আগে আমি বললাম the current is dictated by the load torque, okay, not by the motor. As the electromagnetic torque is dictated by the load torque, so current also dictated by the load torque, and the current will not change in this case. Okay, so if that is the case, if the current remains same, then you can write this expression of omega R1, which is Vt minus IA0 RA by KA phi. Okay,
Sir, RA plus capital RA.
correct. Now it is clear. So this is how we'll get net reduction in speed, because here you see IA0 is constant. That means this negative part is increased. That means the overall numerator will decrease and we'll get a reduction in speed overall. So this is how, by changing the armature resistance, we can reduce the speed from its rated value. Remember, in this armature resistance control, we cannot get increase in speed compared to its rated value. We can decrease the speed only from its rated value. Clear? So that is the limitation of armature resistance control. We can reduce the speed from its rated value. We cannot get any speed which is beyond the rated speed, which is possible in different speed control technique. Now in armature resistance control for DC shunt motor, we can get only reduction in speed by inserting armature series resistance. Okay, is that clear? Do you have any question? Any question do you have? So this point I mentioned, I think in some previous classes, that to have a stable speed, the torque should be balanced. Okay, when this torque, that means electromagnetic torque and the load torque intercepts, then we'll get the stable operating point. Okay, so otherwise there will be either retardation or acceleration. So if TL equals to TE, so it will give us equilibrium speed. Now if TL greater than TE, there will be retardation, and if TL less than TE, there will be, that means TE is more compared to TL, there will be acceleration. Okay, so this is all about this thing you have to remember. Yes, the speed changes is aided by the torque imbalance, initial or transient torque imbalance. The initial torque imbalance helps to decrease the speed only, but ultimately the torque will be at the same value. So therefore, here basically the speed changes due to the armature resistance, the variation in armature resistance or increased armature resistance, as you have mentioned. The speed has been reduced only due to the increased armature resistance. Now here the initial torque imbalance helps to reduce the speed only. শুধু হেল্প করেছে রিডিউস হতে, স্পিডটাকে কমতে। কিন্তু as the torque, load torque is constant, so any other how the load torque can vary? Okay, so the load torque can vary if you change the load. Suppose instead of taking 19th class, if I complete the whole syllabus within 10 classes, then your load will be less. And if I take 5 more classes, that means almost for 24 into 1.5 hours. If that is the case, then the load will be huge to you. Okay, so that means load depends on the uh, load, actual the mechanical load you are giving on the motor. Suppose you are running freely. Now if you are running with a bag on your back, and that bag has a has 2-3 volumes of AK Theresa and BL Theresa, or maybe the volume of AK Shani in your bag, and you try to run at the same speed, then what will happen? You have to exert more energy, isn't it? So more power you have to give to attain the same speed. Are you getting? Suppose you are running freely without any bag. Take that situation. How much power you are giving to run at a speed of suppose 20 km/h? Now when there is a bag on your back having a volume of AK Shani or BL Theresa, and you are trying to achieve the same speed 20 km/h, how much power you have to exert, how much energy you have to exert? Obviously that will be more. So this is how the torque can vary, and the energy you are exerting, that is the electromagnetic torque for machine. Okay, so I am not getting what this Obhijit, who is this? Obhijit Dash. Okay.
Yes, sir.
Okay, so you have your data limit has
লিভ করছি
crossed. Okay, so thank you for
হ্যাঁ হ্যাঁ
you have attended. What is the roll number? Now I will take the roll number. Just I will call the roll.
1074
1074
1074
74. Okay, so you can leave. So I
হ্যাঁ
just completed my class. So let
Yes,
me
sir.
stop the share. So I'll just call the names. So you can leave. I'll stop the share.